Topic 9, Circle Notes, Part 1. So we're going to start learning about the parts of a circle and the equation that represents a circle in the coordinate plane. Some of this may be review from geometry, and if not, then you'll just have to learn it as we go along. So the definition of a circle is the set of all points in a plane such that they are equidistant from a fixed point called the center point. So here we have the center point of our circle right there at that yellow dot. In the coordinate plane, we identify that point as H, K. You've seen those letters before when we worked with the graph of a quadratic. And so we will continue to use those letters as an important critical point of the circle. The length of the segment from that center point to a fixed point on the circle, x, y, is called the radius of the circle. So the length of that segment is the radius of that circle. How do we determine the length of a segment in a coordinate plane? We use the distance formula, which we have written down there. You have used that in geometry. If we want to know how far the distance is across the circle through the center point, we use a measurement called the diameter. And the diameter of the circle is the longest chord of the circle. And a chord is a segment that connects points on a circle. And that chord that is the longest passes through the center point. So if we were to extend this across the circle, we would have drawn in a diameter. And we know that 2 radii equals the length of 1 diameter. What is important also to note in this circle is that the center point of the circle is the midpoint of the diameter. So you see I've put the midpoint formula also in this chart. The midpoint formula helps you to locate that middle point of the diameter, which represents the center point of the circle. XY is identified as any point on the circle. So if we know that the center point is always known as XY, HK, and any point on the circle is identified as XY. And we know that the circle is the result of a set of points that are all the same distance from that center point. Then we know that R is equal to the distance between HK and XY. So let's go ahead and use the distance formula and set up what that equation would be. So R equals the square root of X minus H squared. So you can think of the point as X1, Y1, and the center as X2, Y2. But we're going to go ahead and use HK because that's always the identifying point for the center. So X minus H squared plus Y minus K squared. Now, that is the representation for the radius of that circle. It will always be the distance between any point on the circle and the center. If we square both sides, we get the following. And that is the center radius form for a circle. Now, if HK were positioned at 0, 0, so in other words, if your center point was the origin, or 0, 0, then that equation would become r squared equals x minus 0 squared plus y minus 0 squared, which ends up being x squared plus y squared equals r squared. That is where the equation of a circle comes from. And that will always represent any circle whose center is at 0, 0, and whose radius is the length r. So the equation of the circle comes from the fact that the radius is a fixed length as you move around the circle using any xy point. The distance from that point to the center point will always be equal to r. Two more circle formulas that you should find familiar. Area of a circle is pi times the radius squared, and circumference of a circle is 2 pi r. For this topic, we will not be using the approximation for pi. We will not be using the pi button on our calculator. We will not be using 3.14. We will be leaving our answers as exact. If your circle is translated in the coordinate plane from the center at the origin to the center in one of the quadrants or on one of the axes, then your equation will become x minus h squared plus y minus k squared equals r squared, which is exactly what we got when we derived the formula. And remember, this is just a translation. So if you remember your translation skills, this will be h units to the right and k units down. So if it was x plus h squared, that would mean you would be going h units to the left. So you're going to have to keep track of that when you're locating the center of the circle. Circles don't always come in standard form. Sometimes they come in a general form where you cannot identify the center or the radius by looking at the equation. And so we will learn how to convert it to center radius or standard form. That will be in part 2. All right, so let's review how you find the midpoint of a segment using that midpoint formula. So we're going to let this be x1, y1, so -9, -7, and this be x2, y2. The midpoint is the average of the coordinates. So we're going to add -9 plus 0 and divide by 2, -7 plus -3 and divide by 2. The midpoint is exactly what it says. It's a point, and so it will be the ordered pair that represents the middle of that line segment if you were to graph it in the coordinate plane. So that's going to be -9 over 2. You can leave it like that. That's going to be -10 over 2, which is -5. So you can either write it like that, or you can write it -4.5, -5. And that is the midpoint. How will we use this in terms of circles? We want to remember the center of the circle is the midpoint of the diameter. And that's how we're going to use it in context of circles. How to find the length of a segment when given the endpoints. Okay, the length of a segment, another word we use is the distance between those 2 points. So again, we're going to let this one be x1, comma y1. It doesn't matter. And this point be x2, comma y2. Our distance d is going to be the square root of, and if we look back up here, we're going to see it is x1 minus x2. So that's going to be 4 subtract negative 1 squared plus 3 subtract negative 2 squared. We're going to follow our order of operations, doing our parentheses first. So 4 subtract negative 1 is 5, squared is 25. 3 minus a negative 2 is positive 5, squared is 25. Again, order of operations will say that we add before we square root. So this is going to be the square root of 50. That's going to be the square root of 25 times the square root of 2, which is 5 root 2. So the length of that segment is 5 root 2. All right, how do we determine the center and radius of a circle given the equation in circle radius form or in standard form? All right, in this first form, we see x squared plus y squared equals 81. That would indicate that the circle center is at the origin, representing 0, 0 for hk. So that means my center is 0, 0. Okay, 81 represents our squared. So to determine the radius of that circle, we will square root our squared. So the radius is 9. 3b, how do we determine the center and radius? Well, this is now written in the translated form, x minus h squared plus y minus k squared equals r squared. If we were to translate it from 0, 0, this would be a shift 3 units to the right and 5 units up. So that means that my center point, or 5 units down, because it's y plus 5. So that's going to be a center equal to 3, comma, negative 5. So it's actually the opposite, because in order for it to be y minus k, this would have to be y minus a negative 5. So you have to rewrite it in order to determine what the shift is. So that is a down 5. So left 3, down 5. So my center is at 3, negative 5. 49 equals r squared. R equals 7. All right, so be careful on that because I was wrong when I first said it. So y plus 5 squared, when you rewrite it to the correct form, that would be y subtract negative 5. And that means that the k value of the center is negative 5. The h value is 3. So 3 units to the right, 5 units down. All right, now let's do this the opposite way. Given the center and the radius, now let's create the circle radius form or the standard form. So that means 4 comma negative 7 represents h comma k. R is 12. So I'm going to substitute 4 in for h and negative 7 in for k. So that's going to be x minus 4 squared plus y minus a negative 7 squared equals 12 squared. Simplifying, it's going to be x minus 4 squared plus y plus 7 squared equals 144. You should always square the radius when you provide your final answer, and you should always simplify if you have a minus a negative. Okay, for B, the center 0, 3. So again, 0, 3 is going to represent HK. My radius is 3 root 5. So to put it in the equation, that's going to be x minus 0 squared plus y minus 3 squared equals 3 root 5 squared. The first one, x minus 0, is just x, so that's x squared. The second part, y minus 3 squared. How do we square 3 root 5? Well, we multiply it by itself. It's going to be 9 root 25, which is 9 times 5, or 45. Okay, for 4C, I'm going to go ahead and have you put that into the equation by yourself and put your answer in the box. You can just use the little caret and 2 for the squared part. Okay, so the answer is x plus 6 squared plus y minus 2 squared equals 49. All right. For the last part of these notes, we are going to do some graphing and then some writing equations based on some criteria. So how do we graph a circle? When we graph a circle, we graph the center point first. And so we have to determine the center point. In this equation, x minus 4 squared, so 4 is my h value, y plus 2, so if I want to rewrite that, that would be y minus a negative 2 squared, so that means my k value is negative 2, and my radius is the square root of 9, which is 3. So we identify the center point, so 4, negative 2, so 1, 2, 3, 4, negative 2, that's my center. Now from that center point, we are going to count off the length of the radius in 4 directions. And the easiest directions are to go up 1, 2, 3, to the left 1, 2, 3, to the right 1, 2, 3, and down 1, 2, 3. It ends up looking like a box, but you want to do your best to create a circle. I think in Notability, you can actually expand your circle and, oh, whoops. Well, good enough. If you make the circle and hold it down, like you make a line, it will create a circle. Gives you a pretty decent picture. Let me just see if I can make that be just a little more circular. There we go. Good enough. All right, so that's how you graph a circle. Plot the center, count off the radius, draw your circle. Last semester, we talked about non-linear systems, and we did some work with lines and parabolas. Now we're going to do a line and a circle and talk about that type of system where we have solutions. All right, so we'll start with graphing the line, y equals 3x minus 5. So y-intercept of negative 5, slope of 3, 1, 2, 3, over 1, 1, 2, 3, over 1. Let's see if we can get that. No. Okay. There we go. 1, 2, 3, over 1. Nope, that part was bad. 1, 2, 3, over 1. Okay. There we go. That part looks bad. There we go. A little bit better. Okay, now we're going to graph the circle. So my center is 0, 0. And I'm going to pause for a minute and have you tell me what the radius is. Our radius is 5. So from 0, 0, and I'm going to use a different color now. From 0, 0, we're going to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we already know one of the solutions because we've landed on the same spot. So now let's see if we can get a nice circle from Notability. There we go. All right, we see one of our solutions is right here at, whoa, no, come back. One of our solutions is at 0, -5. But we also know that there's another solution somewhere over there. Now, maybe my line 1, 2, 3 is not so perfect because if I go back to my line and I count from here 1, 2, 3 over 1, now I have the ability to determine that solution 1, 2, 3, 1, 2, 3, 4. So my second solution is at 3, 4. So those are my two solutions, 3, 4, 0, -5. Now, what would I have done if I couldn't identify those solutions from the graph? I would have had to fall back on the techniques that we used first semester, which was substitution. So I would have to go back and substitute 3x minus 5 in for y. I would get a quadratic equation, and then I would solve the quadratic equation. So you should always try to graph first and see if you can get the coordinates from the graph. All right, last two questions. How to write the equation of a circle in center radius form given two types of criteria. So the first type of criteria we're given is the endpoints of the diameter. So the endpoints of the diameter. So if we do a quick little sketch, we don't have to have a perfect sketch. -2, 4, and 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And we draw a segment, right? Looks to me like halfway through is the midpoint. So the midpoint of the diameter is the center of the circle. Okay, so the midpoint of the diameter is the center of the circle. So that tells me I have to use the midpoint formula. All right, so that's on the box on the first page if you don't have it memorized. -2 plus 6 divided by 2, 4 plus -4 divided by 2. That turns out to be 2, 4 plus -4 is 0, divided by 2 is 0. Turns out to be 2, 0, which, pretty good graph for myself there. So now we know that that is our HK. All right? Now we have to come up with the equation of the circle. And so I'm going to write out, we know so far that it's going to be x minus 2 squared plus y minus 0 squared equals r squared. There's our center radius form, or our standard form, okay? I'm going to use one endpoint in the equation to determine the radius. So watch. It's going to be, which one should I use? Let's use this one, okay? So I'm going to put 6 in for x, -4 in for y. So that's going to be 6 minus 2 squared plus -4 minus 0 squared equals r squared. So that's going to be 6 minus 2 is 4 squared is 16. -4 minus 0 is -4 squared is 16. So that means r squared is 32. So please notice how I used the x and the y I substituted them in. It's kind of like point slope for a line. I substituted them in to determine what my r squared is because that was my unknown. An alternative way is to use the distance formula, all right? But this is less work because now I have everything I need for the equation of this circle. So x minus 2 squared plus y squared, because y minus 0 is y, equals 32. And there is my circle. All right, last one. The center point, so we have the center point and another point on the circle. All right, so we already know our HK right there. So we know that we're going to substitute that right away in. So x minus 5 squared plus y minus 1 squared equals r squared. Now we're going to use negative 2, 3 for xy in the equation. So I'm going to substitute in negative 2 for x. So negative 2 is going to go there, and 3 is going to go there. So you can see by my color coding where they're going to go. So negative 2 minus 5 squared plus 3 minus 1 squared equals r squared. All right, I'm going to pause so that you can tell me what r squared is. So go ahead and do that calculation. All right, so 49 plus 4 equals 53. So r squared is 53. So you should have 53 in that blank. Okay, so the equation of the circle is x minus h squared y minus k squared equals r squared.